In question 18 from section 5.1, we're asked to find the greatest common divisor and least common multiple of these two numbers. These are written in exponential form, so this is a number you could simplify, and so is this. But expressed in this way, it makes it a little bit easier to find both of these things. Let's start with the greatest common divisor. We're also going to enter our answer in exponential form, so not as a single number. Please note that when you click in this box like this will appear below. You can use this option here to enter in exponents, and you can use this to separate things that are being multiplied together. So when you go to enter your answer, you'll have to use this and this down here to express it in exponential form. I'll first copy down the two numbers, so that's 3 to the 12th multiplied by 5 to the power of 30 times 7 to the power of 33. And below that, I'll put 3 to the 15th times 5 to the power of 36 times 7 to the power of 32. If you want to be a greatest common divisor, meaning the number that we're going to put in here will divide both this number and this number, we will choose the smaller of the two exponents for each of the prime numbers 3, 5, and 7. So I'll first construct the greatest common divisor. So from here, you have to have a 3, but I'm going to choose the smaller exponent, which is the power of 12. The reason is the number that we're going to put over here, we want it to divide both this number and this one. 3 to the 12 divides 3 to the 12, and 3 to the 12 divides 3 to the 15. If you put a 15 here, 3 to the 15 would not divide 3 to the 12. This is why we go with the smaller of the two when looking at the greatest common divisor. We now move on to the prime number 5, so I'll put multiply by 5, and again I'm going to choose the smaller of the two numbers, 30, not 36. The reason is we want this number to divide both of these. If you chose 36, it would be bigger than this value here, and therefore it would not divide the number overall. Using that same logic, when I use the prime number 7, I'm going to use the exponent of 32, the smaller of the two. This is the answer that you would enter over here. So you'll click in that box, and then using the palette below, you'll use the exponent option to write 3 to the power of 12. You'll include the multiplication dot, then 5 to the power of 30, the multiplication dot, and then 7 to the power of 32. Now let's compare this to the least common multiple. So after you enter in this answer, a new box should appear where you can enter in the least common multiple. Going back over here, if you want to be a multiple of both of these numbers, we're actually going to choose the greater of the two exponents instead of the smaller of the two exponents. The reason is you have to include all of the 3s, all of the 5s, and all the 7s to be a multiple of this number here. So in constructing the least common multiple, we have to have 3. You can choose between 12 and 15 as your exponent, but you want to choose something that's going to work for both, that will be a multiple of both, and that is the exponent of 15. We move on to the prime number 5. Again, if you want to be a multiple of both of these numbers, you have to have at least 5 to the power of 30, but you're going to need these 6 more that appear here to be a multiple of both. And therefore, we're going to choose the greater of the two exponents, which is 36. And then lastly, we have 7. I'll choose the larger of the two exponents, 33. So when we say a least common multiple, it has to be a multiple of both of these numbers. So using just 12 3s wouldn't be enough because you would not be a multiple of this number here. So this is the final answer that you would enter, again, using the palette where you have an exponent option and a multiplication dot option as well.